so Matrix, what I had decided to do was I decided to change our course around. We were supposed to be doing probability this week, but since most of you seem to be writing maths paper 1 on the 9th and paper 2 on the 12th, I thought it would be better for us to just get started on some revision. So the areas that we generally need lots of help with are trig and functions. So that's what I've decided to do with you guys before the exams start. Hopefully we'll also get a chance to do a little bit of Euclidean geometry and a bit of the cubic function before that happens. But yeah, I know that trig is something that normally gets to a lot of us. So yeah, the most practice we will, the more practice we can have with that, the better for us. All right, so typically what we see in CAPS papers is a mixture of grade 11 and grade 12 work. And one of the questions that they always ask us is to simplify an expression to a single trigonometric ratio. So being able to do that is really, really important. And most of the time, this is application of our grade 11 reduction formulae, etc., etc. So I just wanted to go through how one would attempt a question like this, and then I've got a few that I would like you guys to be able to practice. Okay, so being able to do well at trig means that you've learned all your rules. You know all your reduction formulae, you know your identities, you know your identities from grade 11, so your tan identity and your square identity. Otherwise, we're just completely powerless to act. So if you haven't done it already, then you need to make sure that you've learned all your reduction formulae, what happens with negative angles, what happens with angles that are bigger than 360, etc., so that you're able to answer questions like this one. Because the whole reason why something like this is here for 6 marks is for everybody. This is supposed to be a question that everyone is able to access, irrespective of how difficult we find maths. Okay, all right, so let's go and have a look at this, right? So what we're looking for when we look at something like this is what exactly? What are we looking to be able to try and do? Matrix, if I look at sine 140, what do I want to do to sine 140? You can pop it into the chat. What am I trying to do to sine 140? I want to reduce it. Okay, 100%. And which reduction formula I use depends on which quadrant I'm in. So if we're talking about 140 degrees, I'm in quadrant number exactly. Okay, so when I reduce, good stuff. No, Zoe, unfortunately not quadrant 3, not quadrant 1, pleasure. If we've got 140 degrees, it's an obtuse angle, so we would be in quadrant 2. Okay, well done, everybody else. That's perfect. So is sine theta positive in quadrant 2? The answer to that is yes. Remember, we're using our cast diagram, so let's just pop that here on the side, and of course you're welcome to draw one for yourself if you need it. So CAST, of course this is quadrant number 1, this is quadrant number 2, this is quadrant number 3, and over here is quadrant number 4. Okay, so in quadrant 2 sine theta is positive, so sine 140 reduces to positive sine 40. Okay, sine 360 minus x reduces to what? You can pop your answer into the chat. Sine 360 minus x reduces to what, Matrix? Indeed. Good stuff. Well done. Negative sine x, because we're working in quadrant 4. Lovely. Well done, everybody. Good stuff. All over cos 50 can't reduce that because it's already an acute angle. And what does tan minus x reduce to? Again, you can pop your answers into the chat. What does tan minus x reduce to? 100%. Okay, to minus tan x. All right. So that's most of our marks. All right, so at this point over here, I think, well, when I say most, maybe about half, all right, because we've always got to write what we get as a result of reducing. So we would definitely get a mark for this, a mark for this, and a mark for this. Can I leave it there and I let you guys finish the rest, and then we can talk about our answers? Okay, so once you get an answer, so in other words, you've reduced it to a single trigonometric ratio, you can pop that into the chat. Okay, off you go from here. Let's see what you guys do on your own. Shots. Yeah, there's also vegetables there for you. No, Zoe. So what happens with sine 140 is this. Okay, let me do it on the side here for you. Okay, so sine 140, everybody else, you just carry on going, is sine 180 minus 40. Okay, which reduces to positive sine 40. Okay, Zoe? You've got to use your reduction formulae. Okay. Okay, so Oratila says negative cos x, Tsavo says negative cos x. Let's see what other people are getting as an answer. Okay, so Kinsani, you're getting positive cos x. Okay. I'm also wondering why people are getting negative here, because a negative divided by a negative is a positive, isn't it? So what I'm doing here is I'm writing sine 40 times positive sine x, and then I'm going to write cos 50 as sine 40 using my co-ratios, multiplied by sine x over cos x. So that divided by that gives me 1. And now I've got sine x divided by sine x over cos x. So that means I've got sine x divided by sine x over cos x. So now I'm going to keep the first one the same, which is sine x over 1. Change the divide into a times, put the cos x at the top and the sine x at the bottom. Quite right, guys. Okay, and then sine x divided by sine x leaves me with an answer of cos x, yes. Okay, so why does it change to sine 40? Okay, so Tsinolo, Tsipiso, these are your grade 11 co-ratios, okay, which you absolutely have to know in order to be successful at matric trigonometry. Okay, so in other words, the sine of 1 degree is the same as the cos of 89. Or the sine of 30, okay, it's a special angle, is same as the cos of 60. So remember, sine and cos are co-ratios. When it adds up to 90, They're equal to one another. Okay, so I see there's people with hands ups. Who's got their hand up and wants to ask a question? Lerato. Go for it, Lerato. Lerato, you can unmute yourself and ask.
She's off camera, so I think she might be busy.
Oh, okay, all right. Okay, well, we'll see if she comes back and she asks a question. Okay. So only if they add up to 90, then they're equal to each other. That's right, Senola, but only for sine and cos. Okay, only for sine theta and cos theta. Okay, so they are co-ratios. All right, so if the angle adds up to 90, then sine theta and okay, so where this comes from, matrix, is this. Okay, let's do a triangle. Okay, so a right angle triangle, and let's call that A, and let's call that B, and let's call that C over there. Now let's pretend, okay, that this angle over here is 20 degrees, and let's pretend that that angle over there is 70 degrees. Okay, look here, if I write the sine of 20, remember sine of 20 is opposite over hypotenuse, so that would be B over A. Now look what happens when I write the cos of 70. It's going to be adjacent over hypotenuse. It's B over A. Right, so that's why sine 20 and cos 70 are equal to one another. Very, very important for matric. Okay, otherwise you cannot simplify something like this if you don't know your co-ratios. Okay, so very important that you learn that. How are you feeling, matrix? Is that making sense? Are we ready to move on to the next question? Okay, all right. So now here's another one for you. Okay, again, in a typical exam type question. What do you mean it's not making sense to you, Zoe? Everybody else carry on with this question. You're going to have to explain what you don't understand, Zoe, and then Kat and I can try and help you.
Ma'am, can you hear me?
I can, yes. Go for it, Zoe.
So I don't understand from the part where we were reducing sine 40.
Okay, so what we did here is we kept sine 40 as sine 40, and we used our co-ratios to write cos 50 as sine 40.
Okay.
Okay, so in the same way over here, if I've got the cos of 89, I can write that as the sine of 1.
Okay.
So if I've got the cos of 50, I can write that as the sine of 40.
Okay.
Okay, so that's what I've done here. So I've written the cos of 50 as the sine of 40. Then I've used my tan identity. Remember, tan x is sine x over cos x, isn't it?
Yes.
Okay, so I've written tan x as sine x over cos x. A negative divided by a negative is a positive. So the whole answer has to be positive.
Okay.
So here I've said anything divided by itself is 1. So I've got sine x divided by sine x over cos x. Sine x divided by sine x over cos x. And when I divide fractions, I have to tip in times.
Okay.
Okay, so I'm going to keep the first fraction the same, change the divide to a times, and then flip the fraction that follows.
Okay, understand.
Okay, all right, and then sine x divided by sine x leaves me with cos x only. Okay, Zoe?
Okay, thank you.
Okay, no problem. All right, okay, so now I'm not going to say anything. I'm going to let you guys try this one on your own. And again, when you've got an answer, pop it into the chat and then we'll talk about how it's done, okay? Got any questions? Then just message Kat or I to help you. Miss me, has someone finished already? Okay. But Shoko, you've got an answer, all right. Okay, Amanhle got 1. Okay, so we've got -1. We've got 1 so far. Let's see what some of the other students come up with. Okay, Kelebochile, you've got 1 as well. Okay. Sashna, you've got -1. Okay, this is interesting. Persia -1. Oratile -1. Lady got 1. Renewa got 1. Diema got -1. Isn't this interesting, Kat? Lots of different signs here. Okay.
It is.
Yes.
I got a completely different from those two, but we'll see. We'll see. Explain
Yes.
first.
Absolutely. Well, I'm also thinking, because if they're supposed to be, if you were supposed to simplify to a single trigonometric term, then it shouldn't be a number, should it?
I definitely
there we go. Look.
There we go. We're getting somewhere.
Is it Sipile? Got
Yes.
cos 2x. Okay, Larato says
somewhere.
I'm struggling. Neo says root 2x. Oh wow, Neo.
Cos squared x is close to what I got.
Cos squared x. Okay, so we're getting lots of different answers here. Okay, guys, so when it says, like Kat was saying, when it says a single trigonometric term, you shouldn't be getting a number. Okay, you should be getting a sine theta or a cos 2 theta or a tan 3 theta or whatever the case is. But a single trigonometric term is not a number. All right, so there needs to be a sine or a cos Pabalo got minus cos squared theta. It needs to be something like that. Okay. All right. So before we get started, I think a good thing to do with any trigonometric expression or any expression, yes, Renee, where it means you made a mistake somewhere. But Shoko, you've seen your mistake, which is really nice. Well done. That's what we want to help you guys to be able to do. What I would do here, Matrix, is I would look at this and I would say to myself, I have 2 terms. There is the first term and there is the second term. Okay, there are 2 terms in this expression. So I have to multiply tan minus x with cos x with sine x minus 180, and then I have to subtract 1. Okay, so let's start with the first thing, which is tan minus x. What does that reduce to? It reduces to negative tan x. Okay, cos x can't reduce it. So we're going to write it down just like that. Now, when it comes to sine x minus 180, there's two no problem happiness. That's why we're doing it together. Don't worry. Okay, so look at us doing the answer here. Oh, sorry, was it squared? Sorry, Neo. Okay. Look at what we're doing here, okay, happiness. So we've written down tan minus x as minus tan x, okay, fourth quadrant. Cos x, not going to change. Sine x minus 180. What you can do if you want to is you can write that as minus 180 plus x. So I've switched the order of the terms around. Minus 1. Now here in my next line, I'm going to write minus tan x as minus sine x over cos x. See, matrix, the negative only belongs to the numerator or to the denominator, not to both at the same time. Okay, because then it would be a negative divided by a negative, which would be a positive. So only the sine or the cos has the negative. I just make a habit of putting it into the numerator so that I just give it to someone. Multiplied by cos x. Multiplied by. Okay, now what we can do here is we can take the negative out of the bracket. Okay, and that's going to give us x minus 1. Okay, now we all remember that rule that the sine of any negative angle is going to be minus sine of that angle. Okay, so here you can see we've got minus sine of this angle over here. It doesn't matter that it's a binomial, and we can reduce it like this. Okay, so in other words, what we've now got here, matrix, is divide that with that, minus sine x times minus sine 180 minus x minus 1. Okay. So what this now gives us is minus sine x times 180 minus x. It would be positive sine x. A positive times a negative is a negative. Minus sine x minus 1. Multiply these two together. This gives us sine squared x minus 1. And again, if we take out a negative here, we've got 1 minus sine squared x, which then gives us negative cos squared x. Is that what you got, Kat?
Yes, that's what I got.
Okay, all right. So that's what I'm getting as well. Let's have a look. Tommy, you've raised your hand. Sorry, ask a question. Go for it.
Ma'am, can you hear me?
I can hear you. Go for it.
When it comes to when you have sine x minus 180, is it okay if I were to like add 360 because it's a negative number?
Oh, so you mean up here you want to add 360?
Yes, ma'am. And then it gives me sine, what is it? It gives me sine 180 plus x.
Yes, so that would still reduce to negative sine x. That's okay. You can do that. That's not a problem.
Okay, ma'am.
Not a problem. That's one way you can do it. The other way, of course, you can do it if you want to, is you can work on the Cartesian plane if you like. And you can say to yourself, so here, if you're talking about sine, and then here you've got minus 180 plus x. So if we start here at 0 degrees and we go minus 180, that's minus 180 in this direction. So now we're sitting over here. And when we go plus x, we go forward over here. All right, which is what you've just said. All right, so we would end up with negative sine x. We would end up with negative sine x. Okay, so that's another way to look at it. Okay, so Puti, you can do that. You can plus with 360. Not a problem.
Lee,
Yes.
at the bottom, they could have also turned 1 into sine squared x plus cos squared
Absolutely,
x.
absolutely, absolutely, 100%. There's so many different ways to do things like this, isn't it? We could actually be here all night just discussing the number of ways to do that, but you're quite right. You're quite right. So at this point over here, you could have said sine squared x minus, and then here sine squared x plus cos squared x, quite right. So that would have ended up being sine squared x minus sine squared x minus cos squared x, and we still would have ended up with negative cos squared x as our answer. Okay, how's everybody feeling? Is it making sense?
No.
No?
Yes,
What
no.
happened, Lorato?
I don't understand. Why did you say negative cos squared x?
From where? From where did I say negative cos squared x? You mean in the very last line?
Yes, ma'am. You see, it's negative open
Right, so
bracket.
okay, so what I did here, all right, is I let me just move over. Okay, let me see if I can move over the other way. No, I move over now. Okay, so your square identity from grade 11
Yes.
is sine squared theta plus cos squared theta equals 1. So if I leave cos squared theta on this side and I take that over to the other side, I would say that cos squared theta is equal to 1 minus sine squared theta. So if I've got it the other way around and I've got sine squared theta minus 1, I can take out a negative and that gives me 1 minus beg your pardon, sorry. 1 minus sine squared theta and because 1 minus sine squared theta is cos squared theta, I can do that. Okay. Oh, goodness. Oh, sorry. Okay, there's a lot of you that are lost right now. Okay, so all of these are identities. Okay, if you don't learn your identities, you can't do any of this, right? So you've got to know your square identity and your tan identity from grade 11. All right, let's go back since there are so many of you that are stuck.
Okay, ma'am.
Okay, so now the thing is, guys, is that it's not going to help me explaining this again until you do the studying that you need to do, okay? You've got to do the studying. Otherwise, you're going to look at everything that anybody writes in trig and you're going to go, what's going on, ma'am? I don't understand. Okay, because if you don't know the identities, you can't do any of this. All right, so that's step number 1. You've got to go and study and learn the information. Otherwise, you cannot do any of this. All right, so you just can't. You have to go and study. All right, have to go and study. All right, so everybody was okay where we had identified that there were 2 terms in the expression. Okay. So tan minus x, we know is negative tan x. Cos x, we can do nothing to, so we'll leave it as cos x. And sine x minus 180, if you want to add 360 to that, that's no problem. What are we going to end up with if we add 360? We're going to end up with what inside the black brackets? Okay, so what are we going to have inside the brackets if we add 360, matrix? We're going to end up with x, so minus 180 plus 360 is going to give us what? Exactly, plus 180, quite right, Maya. So that's it, Naledi. We're going to have x plus 180 minus 1. Good, lovely. Okay, now we know that the order of the terms inside the bracket doesn't matter. Okay, and we also know that tan x can be written as sine x over cos x. Okay, so that's an identity, all right, that you're all supposed to know. Times cos x times the sine of 180 plus x minus 1. So, because we are multiplying, I can say that cos x divided by cos x is 1. So this leaves us with minus sine x times sine 180 plus x is third quadrant, quite right, Nick. So this becomes minus sine x minus 1.
Ma'am.
Yes, Lorato. Yes, Lorato, go for it.
Where did you leave the negative sign?
I beg your pardon?
Where did you leave the negative sign, ma'am? Because I can see it's positive 180 plus x.
Yes, so 180 plus x reduces to negative sine x, doesn't it?
Ma'am,
Yeah.
I think it would be better if you perhaps expanded sine x minus 180 so that everyone could understand it.
What do you mean expanded it?
Because you know how
because but sine 180 plus x is a reduction formula from grade 11. You're working in the third quadrant.
right, I understand that, but some people don't understand how you got the negative. So I thought it would be easier if you expand, because there's cos 180, which is involved, which is a special angle, and it gives
Where's
you
where's the cos 180, my love?
okay, so ma'am, you're gonna expand, right? It's gonna be sine 180, I mean sine x minus 180. And then when you expand it, it's gonna be sine x cos 180 minus sine 180 cos x. And then sine 180 gives you 0.
But my darling, wait. You are taking something that is so simple and you are making it incredibly complicated. Okay, you don't have to write sine x minus 180 as a compound angle. It's not a compound, it is a compound angle, but it's a reduction formula from grade 11. So you're not going to get any extra marks for making your life more complicated. So like, let me just say to you like this, okay? Like, let's pretend, in which city do you live?
Edenvale.
In Edenvale. Okay, now I don't know Johannesburg very well, but let's pretend I say to you, okay, Lorato, I want you to go from Edenvale to Pretoria. So now you leave Edenvale, you drive all the way down here to Durban, then you drive to Port Elizabeth, then you go to Cape Town, then you go to Dar, and then you go to Pretoria. That's what you're doing. Do you understand what I'm saying? So it's much, much simpler than you realize. And the reason why you're struggling with this is because you haven't done the grade 11 studying that you're supposed to do. This is
That's-
grade 11. This is grade 11 work.
That's true, ma'am.
Okay, so if you study the basics, all of this is going to make perfect sense to you. All right. So in other words, what I was doing here, all right, is I was saying, okay, if I add 360, which is another way of doing it, 180 plus x is quadrant number 3. All right. So in other words, my terminal arm has swung around. It's come to rest in the 3rd quadrant. In the 3rd quadrant, I know that sine x is negative. So the sine of 180 plus x reduces to negative sine x. Exactly. Yeah, that's exactly. It's just a normal grade 11 reduction formula. Okay, I think what tends to happen here is that you guys overthink things and you make it more complicated than what it actually is. All right, so it's not meant to be, you're not meant to expand it as a compound angle. All right, it is, you can treat it like a compound angle, but you don't have to. Okay, there's a much, much simpler way of getting to the answer. Okay, so now when you've got minus sine x times minus sine x, that's going to give you sine squared x minus 1. Okay, but again, you see, you've got to know your grade 11 work so well, because sine squared x minus 1 isn't anything on its own. You have to factorize out the negative and write it as 1 minus sine squared x. And then you can go and sub in and say it is equal to negative cos squared x. Okay.
Ma'am,
Yes, Cabello.
may I ask a question? Since it's sine
Of
squared
course.
minus, the minusing part, you see the one before minus cos squared x, né?
Yeah.
On the formula, you don't even need to take out the minus, because on the reduction formula, it's sine squared x plus cos squared x equals to 1. So if you take 1 that side and cos squared x the other side, it's gonna be sine squared x minus 1, which is equals to minus cos squared x.
Yeah,
So
absolutely.
can you just go straight to the...
So are you saying, can you go just straight from here to here?
Yes, because it's on the reduction formula and all.
It's not on your reduction and on your Cartesian plane, actually. This is the square identity. So the correct thing for you to do here would be for you to factorize. So yes, I wouldn't, that's not a step that I would leave out. The alternative that I would have here was as what Kat had said. Either I would factorize and take out the negative and do as I've done it here, or your alternative is to do what Kat said, which I think is a really nice suggestion, is to go sine squared x minus, and then 1 is sine squared x minus plus cos squared x. That's your alternative. Okay, and then you would have ended up with sine squared x minus sine squared x minus cos squared x. And obviously anything minus itself would be 0, and then you would end up with minus cos squared x like that. That would, I would say, would be your alternative. But I wouldn't leave out factorizing out the negative. I would have that in there.
Oh,
Okay. All right, so that's another way of being able to do it. All right, but you know, again, at matric level, you should be comfortable with taking a negative out of a bracket and the signs of the terms inside changing and then substituting. Okay, but yeah, I think from the red down is probably a little bit easier. Okay, is everybody feeling a little bit better about this question now? Okay, so if anything, you guys absolutely have to go and study your reduction formulae and your identities from grade 11, okay? Because otherwise all of this is just going to be a horrible, horrible, horrible nightmare. Okay. All right, good stuff. Okay, we can do another one, but maybe you'd like to do something else, something that's a little bit different. This one at least has got some matric work in it. I think this is a good one for us to do, but I think it's also going to be a little bit of a challenge. Should we try it? Should we try the one with the matric double angles in it? Yes, okay. All right, cool beans. Let's go for it. Okay, so now you're going to need your matric double angle reduction, sorry, double angle formulae to answer this question, okay? No general solution here, Amantle. It's just a game. So it's just simplifying the trigonometric expression. Okay, Tsonola, no problem. I'm going to do general solutions, but I wasn't going to do it today, Nick. I had planned for us to do general solutions 2 lessons from now. I was going to do identities and general solutions together. So I was going to do another sort of general trig question ratio in terms of a letter, working on the Cartesian plane.
Ma'am,
Yes, Cabello.
can you write down the formula for the different double angle?
Yes. Okay. I was actually going to say maybe that's something that you guys would need. So if you recall, okay, so sine 2a is 2 sine a cos a, and cos 2a can be written in 3 different ways. All right. So either as cos squared a minus sine squared a, or let's just move this question out the way here. Or as 2 cos squared a minus 1, or as 1 minus 2 sine squared a. Okay, so those are your 2 double angle formulae that we work with.
Thank you.
Okay, no problem. Okay, so Nick, you're asking, I think you're saying since sine is compounded, because, what? Since sine is compounded, it because an opposite sign. I don't understand what you're asking exactly, Nick. If sine is squared, then it could become positive, Nick. But if you're talking about the sine compound angle expansion, sine keeps its sign, cos doesn't keep its sign. Is that what you mean? Okay, so, sorry, just 1 second here, everybody. Let's just see. There we go. Sorry, just. So this is what you're talking about, hey, Nick? Our formulae over here. All right, so sine keeps its sign. Cosine doesn't keep its sign, but I don't think that you're using a compound angle here. Okay, again, it's a grade 11 reduction formula. 180 plus x, you're just making life difficult for yourself by expanding it as a compound angle. You want to treat it as a grade 11 reduction formula. Okay, so always use your grade 11 reduction formulae first. Okay, so Amanda, you got -1. Leroy, you got minus sine 2x. Someone else said -1. Sashna, you said sine 2x. Okay, let's see what everybody else has got. Okay, Amanda, you stuck. No problem. Okay, so Amanda, what you should have done is this, okay? You recognize this over here is your sine double angle. And the only thing that you can do with your sine double angle is to expand it to this, okay? So that's what we would have done there. So we would have written sine 2x as 2 sine x cos x, okay? Cos minus x is grade 11, okay? That's got to reduce to positive cos x because we're working in quadrant 4. Plus, Now we've got cos 2x. We don't know how to expand that, right? But I don't know that it really matters how we expand it. I'm going to write here cos squared x minus sine squared x. And then I'm going to write sine 360 minus x as minus sine x. At the bottom, sine 180 plus x is not a compound angle, okay? Well, it is a compound angle, but use your grade 11 reduction formulae, okay, to make your life easy, okay? Don't go from Edenvale to Pretoria via Cape Town, okay? You're not going to get any extra marks for doing more work than what was necessary. So sine 180 plus x is the third quadrant, okay, where sine x is negative. Okay, like so. Okay, so now this is going to give us 2 sine x cos squared x plus, actually, I don't know that writing it like that was the best way. To write it. How did you write cos 2x, Kat?
Well, for now, I left it as cos 2x.
Okay, because I'm also thinking maybe I would leave it as cos 2x.
And then I factored out sine as a common factor so I can cancel it with the one in the
yeah, okay, all right. So I'm going to do the same thing as you. So I'm actually going to rather write that. Yeah, because I'm not sure that expanding that actually helps us, really, does it? Because when we multiply it in, then we're going to have sine cubed or whatever the case is, which doesn't really help us. Okay, so if we just leave that as cos 2x for now, that's fine. Then can you see here, matrix, in the numerator, you can factorize. Okay, we can take, here's the first term. Let's just draw. Okay, here's the first term. Here's the second term. Okay. Remember, terms are separated by plus and minus signs. So now what we're going to do is we're going to take out the sine squared x. All right. So now we're going to take out the sine x. Yeah, just sine x. And that's going to leave us with 2 cos squared x, and then this would be minus cos 2x. All over sine x, but this is negative. Okay, so now what we would do is we would say sine x divided by sine x is 1, but we've still got this negative hanging around here at the bottom. So 2 cos squared x minus cos 2x all over negative 1. Okay, so if we divide something by negative 1, essentially what we're doing here, let's just move all this other stuff out the way, is we're changing the signs of the terms, aren't we? So that gives us positive cos 2x minus 2 cos squared x. And I think now what I would do is I would write cos 2x as 2 cos squared x minus 1. So I'm now going to write cos 2x as 2 cos squared x minus 1 minus 2 cos squared x. And that gives us a final answer of -1. Okay, Maya, I see you got your hand up. Go for it, Maya. What do you want to ask?
Hi, ma'am.
Hi, Maya.
Hi, ma'am. I wanted to ask, what happened to the positive cos 2x?
What do you mean, what happened to it?
Ma'am, because you said before you took out the sign, it was positive cos 2x. So after you took out the sign, it's now minus cos 2x. Why is that?
Yes, because look here, cos 2x up here with the green around it, cos 2x was being multiplied by negative sine x. So positive multiplied by negative is a negative, isn't it?
Yes, ma'am.
Okay, so if I've taken sine x out, then I'm multiplying positive cos 2x with negative 1. That's why it must be minus cos 2x.
Oh, yes, ma'am. Thank you.
Okay, all right, no problem. Anybody else got a question?